Vihdatri is passionate about environmental conservation and the social issues affecting children experiencing homelessness. She has been tutoring homeless kids with Bright Lane Learning since 8th grade and believes that education is key to ending the cycle. She is a Red Cross Youth Ambassador and volunteer who has worked with the National Youth Council to raise awareness about disaster preparedness to homeless youth. Vihdatri is an active member of the disaster recruitment team and a Red Cross Blood Ambassador. She has been recognized by 2 Presidential Volunteer Service Awards for her service at the Red Cross and homeless shelters. Vihdatri cares deeply about the water quality of the Indiana water streams. She has recently developed a novel and rapid method to detect nanoplastics contamination in the wastewater generated by our local neighborhoods. Her method has received wide attention by water experts and the local media. Her work has been featured in the Current and Carmel and Hamilton Reporter newspapers. She was also recently interviewed by Wish TV. Vihdatri has presented her nanoplastics detection method at water conferences, namely the Indiana Water Summit and the Indiana Rural Water Fall meetings. She has been invited to present to 2 additional water conferences this coming fall. And I will tell you, she is only 14 years old. I looked up your birthday in core. You're not even 15 yet. You aren't 15 till late spring. You're a young child in your class. It's truly amazing, and it is a pleasure to have you here tonight. So now I will give you the stage. Vihdatri.
Thank you, Ms. O'Malley, for that wonderful introduction. Okay, so I'm Vihdatri Iyer, and I'm here to talk to you about detecting nanoplastics in our water. So a little bit more about me. I graduated in 2022, so my memories of Sycamore are still very recent. I'm currently a freshman at University High School, and I also have a brother who graduated here 4 years ago in 2018, so we're a very Sycamore family. So today I'm going to be talking to you about a new technique I've developed to detect nanoplastics. So a little bit more about nanoplastics. A nanoplastic is a very small plastic that is broken down from these bigger plastics that we throw into our landfills and our oceans and water. And so why nanoplastics are so significant is because they're so small, there's only really one way to detect nanoplastics, and that's through spectroscopy. And the problem with spectroscopy, it's a very big, expensive lab technique that many labs cannot afford. So because of that, the research of nanoplastics has gone overlooked for a long time, and that's created a knowledge gap. So my goal of my method was to find an easy, affordable, one-step nanoplastic detection method that could be used by smaller field researchers and labs so that they could look at the nanoplastics of a water sample in just under 10 minutes. So a little bit about my method is that I use these 2 key elements for my method, and the main instrument I used was the handheld fluorometer. And what a fluorometer does in simple terms is it looks at the amount of fluorescence particles emit from a water sample. So using Nile red dye, which is the second agent in my method, I'm able to see how many nanoplastic particles are in a water sample. So to go further into my sample analysis, the first thing I do is I filter whatever water I'm sampling with a 0.4 micrometer syringe. I then add 160 microliters of that water sample to a 0.3 ml mini glass tube, and then I add my Nile red dye to it. And then I leave it for around 10 minutes to allow the Nile red dye to attract itself to the plastic, and after it attracts, I read it with the fluorometer, and I'm able to get a successful nanoplastic reading. So there was definitely a series of events that led me to create this technique, and most of them started right here at Sycamore. So this has been a project that's been going on over many years, and I first found my passion for this project in 3rd grade. And this came from a trip to the Himalayan mountains, where I've looked at the amount of pure water that has been polluted by our planet, and that's where I really found my passion. I then took a tour of TRICO, which is a wastewater treatment facility. So they take in 6 million gallons of water each day and from our local homes and neighborhoods, and then they treat it and they reintroduce it back into the environment. And so this was really a lab where I could grow and continue my research. I then went to ISEF, also in 6th grade, and this is the International Science and Engineering Fair, and it's the first conference where I presented my water work. And it wasn't exactly on nanoplastics, it was just about water in general, and I won my first award there, and so that really helped me pursue my career and path into water sciences. And then from the span of 6th to 9th grade, 3 whole years, I started working on perfecting my technique to find nanoplastics. So it was a really long and tedious process. But finally, now in 9th grade, I've perfected my technique, and I'm able to start going to different water conferences and present at different competitions. So a little bit more about where my passion really started. So like I said, in the summer of 2016, my family took a religious pilgrimage to the Himalayan mountains. So we followed that blue line in the first map up there from the northern part of India into Nepal, which is a country that's sandwiched between China and India. And basically, the whole point of this pilgrimage is to circumnavigate a main mountain, which is in the bottom center picture right there. And it's to circumnavigate that mountain, which is known to be the home of one of our gods. So I was actually the youngest person in this travel group, as you can see in the yellow circles right there. And so it was really an awe-inspiring experience for me, and basically you just trek along through the mountains, through these gorgeous mountains and gorges, as you can see on the far left. And while I was there, I saw one of the most purest water sources ever. The mountains are where we get 90% of our pure drinkable water. And so while I was up there, it was just so pure and so untouched by man, it was awe-inspiring. And then when I came back, I realized how much pollution we're really putting into our earth. With the cars we drive, just every day, we dump so much pollution into our earth. And I realized that was something I was really passionate about, and I really wanted to go into it. So like I said, in 6th grade, I started working with TRICO, which is a wastewater treatment plant. And TRICO is where I really started to learn my love for research, and I was really helped by my mentor, Mr. Bob Bush, who happened to be the lab coordinator at TRICO. And he was also one of the only people who'd let a 12-year-old in his lab. So I was really grateful for him. He really helped me with research and just being in a lab setting, because I hadn't really been introduced to that yet. And so at TRICO, I really started working on my research, and he kind of gave me free rein and was really there as a guiding force to help me. And so there is where I later started pursuing my passion to find this nanoplastic method. So a little bit about reaching out. So the whole point of my project was to reach out. I wanted this method to be for people who could not afford that bigger lab technique. So I started reaching out to various organizations. I reached out to the River Alliance of America and the Marion County Public Health Department. And with their help, I've been able to look at the nanoplastic load in 80+ Indiana main water streams. I've also presented my method at various water conferences around Indiana, and so far I've been getting really great outreach from a lot of the water scientists with a lot of offers to help me continue my research and some scholarships. I've also competed in competitions such as Junior Symposium and ISEF, which are all competitions that allowed high school students to share their research with the world. And so a little bit of where I am now. So I competed in ISEF, which is the International Science and Engineering Fair, and I was able to advance into the state level, where I won first place for my 9th grade division. I then was chosen, thank you. I was then chosen to be one of 18 students to compete in Dallas this May to represent Team Indiana for the whole of International. I'm also hoping to continue my research with the nanoplastics and to continue presenting my research in various different water conferences. So a little bit about how Sycamore helped me. So I'm sure all of you know Sycamore has an extremely supportive community. I remember in 3rd grade when I really wanted to try funny bones, but I was too scared to admit it, but Miss Stewart pushed me, and it ended up being one of the best things I've ever done in my life. That leads right into the teachers. My teachers, even if I push back a little, they always push me more and push me to be my best. And so I'm eternally grateful for them. And also just the high achievements and the competitiveness of my peers. I didn't realize how much competitiveness my peers gave me until they weren't here anymore. And I'm eternally grateful for that because they always pushed me to be my best. Thank you.
The middle schoolers had a lot of questions today. I mean, it was about 12 or 15 minutes of questions for each. Yes, it went until almost 3:20. So does anybody have a question that they'd like to ask Vihdatri?
Yeah.
Thank you. Thank you for that presentation. That was very inspiring. We were just reminiscing about how equally competitive and motivating our class was, and it's nice to know that that hasn't trailed off whatsoever. I wanted to ask you two questions. One is, when you've measured different water samples throughout Indiana, what have you found in terms of microplastic content? And then, generally speaking, are there health implications to microplastics that we're aware of, or is it more of just like that's gross kind of thing?
Yeah. So while looking at the various water streams around Indiana, we actually found very low levels of nanoplastics, which is great because that means there's not that much plastic pollution. But we're hoping to see if there is any plastic pollution, we can start lowering. We can try to figure out where that plastic's coming from. Also, for health implications, it's really bad if it's in our bloodstream. Any more than 10 microgram per ml can be very dangerous to our health. So while it is gross, it's still pretty dangerous.
Awesome, thank you.
Yeah.
I was wondering what courses, as you go on and advance in academia, will help you in your career, and what final result would that put you in?
Yeah, so I know my high school offers an environmental sciences course, which I'm really excited to take because that's kind of right up my alley with this project. And I'm also hoping to pursue a career in environmental sciences and hopefully get more into the water field, so those will definitely help further my knowledge with water.
So there's a lot of classes
There is, yeah,
that you can take?
environmental sciences is getting pretty big as a field.
Okay, great. Well, it was wonderful. Thank you.
Thank you.
Thank you for a wonderful presentation. I was just complaining that I wasted the first 30 years of my life because I was seeing what you've done here. So well done. I have two questions scientifically. Number one, how did you arrive at using the red dye? And number two, as a corollary, how did you validate the findings? Against what?
So I didn't want to bore you guys too much with the science stuff, but for the validation, I did have a standard curve using polystyrene beads, which are just pure plastic, and so that's how I validated. And I also came up with Nile dye, because Nile dye is one of the newer dyes on the market right now, so they're still trying to figure out what Nile dye is being able to used for. So I decided to look at that newer dye and just use it in my experiment.
Very good. Thank you.
Yeah.
I'm pretty ignorant when it comes to plastics, and I didn't know it was different degrades. So what is nanoplastics? How is that different, and is it biodegradable or recyclable?
Yeah, so plastics are actually defined by their size. So a regular plastic, which we can see by our human eye, is greater than 5 millimeters. And so the next level down low is microplastics, and that's anywhere from 1 micrometer to 5 millimeters. And then nanoplastics are the smallest size of plastic particles, and they're less than 1 micrometer. And so they're not biodegradable. No plastic is so far right now. They can be recycled, but most of them end up in landfills and the ocean, and so that's why they're such a big problem.
Okay. Vihdatri Iyer, class of 2022. Only 14 years old and already making a difference in our community, in the home through the homeless work as well.